So what did we discuss yesterday? In the first session, we have discussed about machine learning, and what we have done is we have seen how do we develop a machine learning model. And yesterday there was another machine learning model which was given to you, probably hoping that you have done or understood something. Okay. Now, when we talk about machine learning, what did you understand from machine learning concepts? Machine learning is all about what? Giving machine the ability to learn, just like how humans learn, without explicit programming, and not just learning but also improving the performance by past experiences. This is what we have studied about machine learning. Okay, so we have seen different learning systems or learning methodologies in machine learning, where we have seen supervised learning, unsupervised learning, and reinforcement learning. So basically we've seen that there are two most important algorithms that covers all the real-time problems. They are regression and classification. So when do we use regression and when do we use classification? Regression is used when the output variable has continuous values. Classification is used when the output variable has discrete values. And we have seen two types of classifications again, binary classification and multi-class. If the output variable has two classes, yes, no, I have fever, I don't have fever. Okay, so this is called as binary class. I have mild fever, I have high fever, I have no fever. Multi-classes is called as multi-class classification, right? So we have seen different algorithms, and then we have seen how do we develop a machine learning model. Okay, so we have seen 7 or 8 steps, right? So how do we develop a machine learning model? First we import the libraries, we collect the data, analyze the data, pre-process the data, and then divide the data into train, test, split. What is the need for dividing the data into train and test? Because we want the machine to understand and learn with respect to training data. Once the machine gets learned, I want to test if the machine is working well or not with respect to my test data. So we do train, test, split. After that, we train the model. How do we train the model? By using fit function. So we have predefined libraries like sklearn, TensorFlow, and PyTorch, where all the functions corresponding to the classic machine learning algorithms are available. So we just use that function and then use fit. How do we fit the model? With respect to this function. After that, we have to train the model with respect to xtrain and ytrain. So when I split the data, I have 4 things. I have x and y. What is x and what is y? X is input, y is output. When I divide my data into train and test, I have xtrain, which is training input. I have ytrain, which is training output. I have xtest, which is test input. I have ytest, which is test output. So how do we train the model? With xtrain and ytrain. So I give the input, I also give the output, and tell machine understand the patterns in the data. Once the machine understand, I'll apply xtest, I'll hide ytest, and ask the machine to predict. So that I call it as y prediction. So there are 5 things: xtrain, ytrain, xtest, ytest, y prediction. I train with respect to xtrain, ytrain. I test with respect to xtest and find y prediction. Okay, so the machine has done its job now. Now how do I test if the machine has done proper job or not? By calculating loss. How do I calculate loss? Actual value minus predicted value. Actual value is y test. The prediction value is y prediction. So this is called as what? Loss calculation. Okay. So for regression, we use MSE or MAE, mean square error, mean absolute error. For classification, for binary classification, we use binary cross entropy. For multi-class, we use categorical cross entropy. So we have 3 different loss functions: mean square error or mean absolute error for regression model. We have binary cross entropy for binary classification, categorical cross entropy for multi-class classification. Okay. So this is what we have seen. So how do we calculate the accuracy? If loss is 40, accuracy would be 60. Okay. Apart from what is loss, the rest of that would be the accuracy that the model has performed. Okay. This is what we have seen in the first session. Right. So today let's switch on to the next subset of machine learning, which is what? Deep learning. So I've given you 2 things. AI is the broader picture. Machine learning is the subset of AI, and then deep learning is the subset of machine learning. So once we are done with machine learning, we'll see what deep learning is all about. Okay. Now, what was the first difference that I told you when I was talking about deep learning? Yes, machine learning algorithms will not. See, we have few disadvantages of machine learning, right? What were they? First thing is machine learning works well, but only with limited data. Okay, and then feature extraction has to be done by us. Okay, by the programmer or us. Okay, human intervention is required when I talk about feature extraction. Okay, and then machine learning will not give you good results if you go for large data. Machine learning algorithms would work well only with numerical data. But apart from numerical data, we have seen 4 types of data. What were they? We have numerical data. When I talk about numerical data, weather prediction or stock price prediction, where I have values, they are called as numerical data. But when I talk about chatbots, when I talk about machine language translation, all this comes under what? Text data. When I talk about Siri and Alexa, voice data. Okay. When I talk about face recognition, image data. So machine learning algorithms, though can handle all these 4 different types of data, they work well only with what? Numerical data. Okay. So machine learning algorithms does not have that, that much deep understanding on the images or text or voice, because these are complicated data. Why complicated? When I talk about image, how is the image represented? Pixels. Okay. ఒక చిన్న simple image of size 10 by 10 తీసుకుంటేనే 100 pixels, 10 rows, 10 columns. మనకి image square లాగా ఉంటుంది కదా, 10 rows and 10 columns. 10 into 10 is what? 100. So I require 100 inputs to process that image. ఒక చిన్న image of size 10 by 10. ఒక్కసారి నా కెమెరాలో ఇమేజ్ ఓపెన్ చేస్తే the size would be around 1028 into 1028 or more than that in fact. So 1028 into 1028 అంటే ఒక్క ఇమేజ్ ప్రాసెస్ చేయడానికి takes this much time. So when I talk about processing some million images, so imagine how many number of inputs we have and how much complicated the network would be. Okay. Similarly, when I talk about language, as I told you, we don't have one language in the world. We have different languages, we have different syntaxes, we have different syntactics when I deal with what? Language. As I told you, Telugu itself has n number of versions, right? So nobody knows all versions of Telugu. Yes or no? Maybe you know, but 1 or 2 exceptional cases. Okay. So the same way, when I talk about text processing, text in the sense all language, grammar, syntactic, everything should be processed and accurate results should be given. So imagine how complex processing text data would be. Okay. So simple machine learning models won't have that capability of, they will do, but they'll take decades to do that job. So it's of no use when you say, I can do something but give me 10 years to do that something. Meanwhile, I have 3 generations getting born and then they'll do more advanced things than what we do. Yes or no? Okay. So for that reason, we don't use machine learning models for advanced applications which involves basically the text data or voice data or even image data. Okay. So the reason why machine learning is not able to do all this is because machine learning are simple not algorithmic based model, a simple, though they are not explicitly programmed, they are very simple models. Okay. So when I say how humans work, I want machine to work like how human work. Humans have what? Brain. We work because we have brains. Okay. So when I talk about this, the neural network concept have come into picture. So why not we add these neural networks or neurons to the machine learning models? It is the same. Deep learning are also machine learning models only. But apart from the basic machine learning models, we add these neural networks to ML models. What do we do? We add neural networks to ML models. So just understand, deep learning is all about machine learning with what? Neural networks. Okay. Let's see what are these neural networks. Okay. So what are neural networks? Look at the exact definition. Neural networks and it has brain atla cheppoddu. Only one line definition of neural networks. What is that? Neural networks are computational models inspired by human brain. Neural networks are what? The computational models which are inspired by human brain, and they consist of what? They consist of some nodes or neurons which are organized into layers. Okay. So 2 points about the neural networks. What is that? First one is neural networks are what? The computational models which are inspired by what? Human brain. Second point, how are they organized? How do they look? They have some neurons organized into some layers. Okay. Next, what do they do? What do the neural networks do? Okay. What is that second point? Neural networks are capable of learning from data. Same like machine learning model. They're not doing anything extra. They're also doing what? They're also learning from data. Okay. And making predictions. Even machine learning does that. Okay. Without being explicitly programmed. So is there any change here? So what are neural networks doing? Neural networks are learning from the data, making predictions without being explicitly programmed. But what is the difference between machine learning and deep learning? We just have neural networks associated with deep learning models. Okay. So like we have these neurons in our brain, we have this neurons in the neural networks. Okay. So why is the name neural network? Neural is all about neurons. Network is all about connection between these neurons. Okay. So this is a simple neural network. So what do you observe in this figure? You observe some round circles, right? Yes or no? So how many colors of circles do you observe here? 3. The first one is called, the green circles is called input layer, which has 2 neurons in it. What is that first one called as? Input layer, and the circles are called as neurons. The second one is called hidden layer. The second one in blue is called as what? Hidden layers, and there are 4 neurons in that. And the third layer is called as the output layer, which has only 1 neuron. Okay. So how many layers are there in the neural network now? 3. What are they? Input layer, hidden layer, output layer. Okay. Now I'll tell you what happens in each layer. The input that we take will be given to the input layer. The hidden layer is the most important part of the network, which will do all the processing. Input layer will only take the input. Okay. The hidden layer does everything. What does it do? It takes the input from the hidden layer and process that particular input and pass that input to the next layer, which is called as output layer, where the output would be displayed or output would be taken from. Okay, so how many layers in the neural network, guys? 3. Input layer, hidden layer, output layer. Okay, now the second question which comes into your, you should get that question. How many neurons do we take in each layer? Okay, madam, input layer boundi, hidden layer boundi, output layer boundi. But why did you put only 2 there? Why did you put 4 there? Why did we put 1? Okay, I'll tell you that. We have to only give the number of neurons in the input and output. That too we don't give. The machine automatically takes when you give your data set, because as I told you, deep learning low, the feature extraction would be done by the model itself. Feature extraction and how many inputs are there, how many outputs are there, all that. Okay. Now, the number of neurons in the input layer depends upon the size of the data that we take. Okay. So, if I have 10 samples, 10 neurons. If I have 100 samples, 100 neurons in the input layer. Regression model anko okate output continuous values vastai. So, only 1 neuron. Binary classification anko okate neuron, either that or this. Multi-class classification anko enni classes unnayo anni neurons pettukovali. Is that clear, everybody? So for regression model, we have only 1 output. For 1 input, we get 1 output, different classes. For binary classification, yes or no. So only 1 input, 1 output. That would be either that or this. Whereas for multi-class classification, I can't do that. I'll put the number of neurons as per that. I'll show you that. Don't worry about it. Is that clear now? How many neurons in input layer depends on what? The size of or the instances of data that I have. If suppose I have a data set of all your details, I have 495 students originally in this batch. So how many neurons do I take in the input layer? 495. My output is your pass percentage of the last semester or your CGPA of the last semester. So I give only 1 input at a time, right? I want to know the CGPA of this person. So I need only 1 output for this person to display, because I don't want to read the data of everybody. I want to just Give one input and check what is the CGPA. So I take only one neuron. This is how we design number of input layer neurons and output layer neurons. The number of hidden layer neurons again would be automatically designed by the machine based on the connections that it takes. So even for input and hidden also we won't give anything. I am just telling for your reference or explanation how does that take. Okay. This is called feature extraction, which would be done by the model automatically. We won't do this. Okay. So how many layers? 3. Okay. This is called a simple neural network. Okay. So what does the hidden layer do? Hidden layer process the input. Okay. Now when I talk about processing the input, he has different IQ level, he has different IQ level. He can understand something only if he read once. He'll understand something when he read twice. He'll understand something when he read thrice. So he needs more processing for him to understand something. So hidden layers lo same thing happens. Okay. If you want to understand the content, if you want the machine to understand the patterns of the data or insights of the data, you have to add more hidden layers. What do? We add input layer, add j. Input layer will also always be 1. Output layer will always be 1. So what would be changed? The number of hidden layers. The more hidden layers we add, more depth the information would be processed. The machine will understand more insights of the data. Is it clear everybody? Yes or no? Yes. Okay. So what does input layer do? Also known as input nodes are the input information from the outside world is provided to the model. Input nodes pass the information to the next layer, which is called as what? Hidden layer. Look at hidden layer. Hidden layer is a set of neurons where all the computations are performed. On the input data, there can be any number of hidden layers in the neural network. The simplest neural network consists of what? Single hidden layer, like what we have seen in the previous figure. The output layer is the output conclusions of the model derived from all the computations which have been performed from the hidden layer. Okay. So there can be single or multiple nodes or neurons in the output layer. If you have binary classification, we have output node as what? 1. If you have multi-class classifications, the output nodes can be more than 1 depending on how many classes you have. Okay. Now, we're talking about neurons, right? That one simple single neuron is called as perceptron. What is that called as? Perceptron. Okay, it takes input x1, x2, x3, whatever variables you have, and then it produces some output which would be connected to another neurons. Okka neuron nunchi inko neuron ki connection would be there. That is the reason we call neural network. All the neurons would be interconnected from input layer to hidden layer to output layer. So that each neuron is generally referred to as what? Perceptron. Okay. Now, when we talk about neural networks, we have these 3 types of neural networks. Okay. So we have artificial neural networks, we have convolutional neural networks, we have recurrent neural networks. What are the 3 types of neural networks, guys? Artificial neural networks, convolutional neural networks. Okay. Now I'll tell you when do we use each one of them. ANNs are just advanced ML models. ANNs are what? Advanced ML models. When I say ML, they take numerical data. So ANN also deal with what? Numerical data. They cannot process image data. They can, but as I told you, takes time. Computational cost would be high. Time taken would be more. Speed would be less. Okay. Complexity would be more. Okay. So ANNs deal with what? The numerical data. Convolutional neural networks deal with image data. What do they deal with? Image data. Recurrent neural networks deal with the sequential data, where when I talk about sequential, is sequential numerical ostadi, like stock price prediction, weather prediction, okay, where I want sequence of data to be processed in order, okay, and then natural language processing task, NLP task like text processing, machine language translation, text summarization, chatbots, queries, email, all this comes under your sequential data, which would be done by using recurrent neural networks. Okay. Apart from this, recurrent neural networks also process voice data, because even my voice is sequential. When I say I am ASHA, it should be in this way. I can't say ASHA am I. Yes or no? So you'll understand what I'm talking if I process my lecture in sequence. Yes or no? First ఏదో చెప్పేసి చెప్తే మనకి ఏం అర్థం కాదు. Same thing goes here. Okay. So what does ANN deal with? The high numerical data. So what is the difference between ML model and ANN model? The very small data can be handled by ML. Huge and complex data can be handled by ANN. So when do we use CNN models? Image data. When you have image data. When do we use RNN models? When you have sequential data, sequential numerical, sequential image, sequential text, sequential image sequential numerical, sequential text, sequential voice. Are you all clear with when do we use ANN, when do we use CNN, when do we use RNN? Yes or no? Yes. Now I'll tell you some applications. Tell me which type of neural network do I use. Okay. I want to process your pass percent CGPA after you graduate of one class. I'll use machine learning model, not ANN. One class, only 60 samples. So I use what? Why do I go for ANN? I use what? Machine learning model. Overall pass percentage of the outgoing students of 23-24 of KMIT, then ANN, because overall pass percentage of all the passed outs ante there are almost me batch meedi KR 23 అయితే 780 students, 780 without lateral entries. Okay, so we use what? ANN. So one class machine learning model. Calculating CGP of the entire outgoing batch, I use what? I use ANN. I want to develop a model and keep it at the gate such that it identifies whether he is our student or not, and then give him the entry to the college. So scanning of that particular person is image processing. So we use what? CNN model. I want you to develop a chatbot for the website. RNN model, because chatbot is okay. So depending on the input that we take for our application, we use either a machine learning model or a deep learning model where I talk about ANN, CNN and RNN. Okay. Now what is the difference between the first figure and this figure? I have multiple hidden layers. So this is called as multi-layer perceptrons. What is perceptron? Simple single neuron is called as what? Perceptron. So this is called as what? Multi-layer perceptrons, because I have multiple hidden layers. Don't say multiple input layers, multiple output layers. Multiple neurons will be there in the input and output, but we have only one input layer, one output layer, but we have multiple hidden layers. So this network is called as what? Multi-layer perceptron. Okay. Now, how can you explain about this figure? How many input layers we have? One. With how many neurons? 6. How many hidden layers? 2. With what? Each hidden layer of what? 4 neurons. And how many output layers?
1.
Is that clear? With how many neurons? So this is how I say. An input layer with 6 input nodes. First hidden layer with 4 nodes or perceptrons. Second hidden layer with 4 nodes. And then finally one output layer with 1 node. This is how we define the network. Okay? What do you observe in this diagram? Don't read the name. What do you observe is what I'm asking you.
One input layer, multiple hidden layers.
One input layer,
Multiple hidden layers.
4 hidden layers, one output layer. So more number of hidden layers are been added. So this is called as deep neural network. Andukane the name deep learning. So this kind of network is called as what? Deep neural network, or we call it as what? Deep learning. Okay. So what does an ANN architecture do? Takes the input, process that input in the hidden layers and produce the output. Okay. So what are the two images that you see? Dog and a cat. That will be processed. That will be given to the hidden layer. That will be taken by the input, processed by the hidden, and then the output would be displayed. Dog aithe dog image highlight avutundi. Cat aithe cat image vastundi. Okay. Yes. This is most important part. So this is basic understanding about what neural networks are, how ANN looks like. Okay. So The entire operation or understanding is done where? The computations are performed in which layer? So we will understand what hidden layer does now. Okay. So what do you observe in this figure? You find x, x1, x2 till xn. You also find w1, w2 to wn, and then I see one threshold unit. Okay, I see some summation, and then based on that I am taking my output, right? So that blue circle that you have, okay, the diagonal thing that you have is a neuron in the hidden layer. Okay, I'll explain you what does that neuron do in the hidden layer, because as I told you, all the computations will be performed in the hidden layers. So now let's see what does the hidden layers do. Okay, so before we actually see what hidden layers do, let's say I have 60 students in the class. Okay, I want to train my model with the data of these 60 students. Okay, and then generate something. Okay, now when I don't find proper results, that is, I find there are so many students with less than 50% of marks. So what do? I have to train those students who are having less than 50, such that I improve the performance of them. So I am talking about what? I take the data, I analyze the data, I get the output. Okay, when I got the output, I observe what? There are many improvements that has to be done on the data. Many improvements in the sense, if suppose I have 60 students and I observe the results, if I don't find good results, I have to train them more and teach them more. Yes or no? So do I have to teach them more, or do I have to replace them to get good results? If I get very bad results for this set of students, do I have to teach them to improve the performance, or just say you go, you come, I will teach you and you get good percentage? Teach the existing data. I don't want to change the input. I want to change the teaching methodology such that they'll understand and get good results. This is my aim. What is my aim? Train them such that they'll pass. So I don't want to change the inputs, but I want to add something to the input such that I can do training. Those things are nothing but the weights. Those things are nothing but weights. So I don't take the input directly. What I do is I add some weights to the input and check the performance. If the performance is not well, I won't change the input. What will I change? I'll change the weights. I'll change what? Weights. So only if I process the input, nothing will happen. Yes or no? So what do? I change the weights. I have two options. Either I have to change my teaching methodology, or I have to ask somebody else to come and teach so that you'll understand. Yes or no? So I have to change the teaching only, not the students. So I won't change X, but I want to change what? The weights. So andukane, when we take the inputs, we don't just take the inputs. We multiply the inputs with weights. What do? We multiply the inputs with weights. Okay? Our weights, inputs, multiply aynaya leda ani oka hidden layer ni activate cheyadaniki we use one thing called as bias term. We use what? Bias. So now observe the first part in that blue circle. Summer lo undi kada. So what do you observe there? Summation of I is equal to 1 to n. I is equal to 1 to n ante the 60 students. I is equal to 1 to 60. The summation of all these. Inside what? Inside that what am I putting? X into W plus B. What is this X? Inputs. What is this W? The weights that I am adding for each input. Weights anni inputs kokata add cheyanu. I add weights to different inputs. And all together, after I do this, for one hidden layer, I'll add one term which is called as what? Bias term. Is it clear, everybody? So that is called as the transfer function. What is it called as? Transfer function. Summer and undi kada. So what is the formula for transfer function? Summation of I is equal to 1 to n xi wi plus b. Xi wi అని ఎందుకు అంటున్నాను? Because I have x1, x2, x3 till x60. So I add weights for what? W1, W2, W3 till W60 plus only one B1 to B50 ఉండదు. ఒక్క హిడెన్ లేయర్కి only one bias term. Are you all with me? Yes or no? Did you all understand what is transfer function? So what is transfer function? Multiplying some weights with generating some random weight. Then you can ask me, madam, from where will we get these weights? Input ante mana input data. Where will we get weights? Randomly the weights would be generated by the model. Manaki numpy lo rand function undi kada, RAND random function. Using that function we will randomly generate these weights. Okay, so we randomly generate weights, multiply these weights with respect to the inputs and add one bias term to it. How many weights do we generate? How many number of input samples we have? That many weights would be generated and they would be multiplied. With that, a bias term would be added. Is that clear, everybody? Now, this is first part of the functionality of the hidden layer. Hidden layer does two things. First one is calculating the transfer function, which is summation of Wx plus d. This is bani. Next, what I find is, I have 60 students in the class. I am training them 100 times, but there are 2 students, even if I train 1000 times, it is of no use. Well, in change avvatledu. Ante they are like that. Their IQs are like that and I can't help. So, ఇప్పుడు 60 మందిలో ఫస్ట్ 20 మంది ఫెయిల్ అయ్యారు. ఓకే, ఐ ట్రైన్ 2 టైమ్. ఫస్ట్ టైం ట్రైనింగ్కి ఆ 20 ఫెయిల్లోంచి 18 పాస్ అయ్యారు, 2 పాస్ అయిపోయారు. సో అగైన్ 18 స్టిల్ ఆర్ ఫెయిల్. సో ఐ ట్రైన్ ఇట్ అగైన్, ఇంకో 10 మంది పాస్ అయిపోయారు. ఐ స్టిల్ హ్యావ్ 8. ఐ ట్రైన్ అగైన్, ఇంకో 2 పాస్ అయ్యారు. ఐ స్టిల్ హ్యావ్ వాట్? 6 failures. I train again, nobody passed. I train again, 4 passed. I train again, 2 more passed, 2 are left. I train 20 times again, but these 2 are still like that. So do I still continue doing that till I get old, or do I stop it there and say, Baba, this is not my job, you can check whatever you want, this is not out of this? Yes or no? So the neurons will have some function called as activation functions. There are some functions called as what? Activation functions. So once we train the models, once we calculate the transfer function, we apply activation functions onto these transfer functions. We apply activation functions on these transfer functions. So we have 2 operations being performed in the hidden layers. One is transfer function calculation. The second one is applying activation function on the transfer function. Is it clear? So the activation function will identify the neurons which have data and then pass that data to the output. If the activation function does not find any particular data in the neurons, and if it finds it is of no use, it will not process them, keep them there and then go to the output. Is it clear, everybody? Yes or no? So let's go back again. How does a neural network looks like? Input layer, hidden layer, output layer. More number of hidden layers, what happens? More deep the neural network gets trained. More deep the neural network gets trained. Okay? What does hidden layers do? They perform computations. What are the 2 important computations which are being performed in the hidden layers? Transfer function calculation and activation function application on the transfer function. So there are 2 terms that I'll use throughout the program, embedded learning program. Okay, so we call the transfer function as Z1. Z1 is equal to summation of Wi xi plus b. Okay, now I say A1 as activation function applied on Z1. I'll repeat. What is Z1? Summation of Wi xi plus b. This is what? The transfer function. Okay. What is A1? Activation function applied on the transfer function. So A1 would be f of Z1. A1 would be f of Z1. This is what if I have one hidden layer. A1, Z1 are corresponding to what? One hidden layer. If suppose I have second hidden layer. Suppose I have second hidden layer, I'll have Z2. I will have what? Z2. What would be Z2? Transfer function. What would be A2? activation function of Z2. Are you all with me? Okay. Now, input is connected to first hidden layer. First hidden layer is connected to what? Second hidden layer. Input is not connected to second hidden layer. As you can see in the diagram. Yes, look at that. Input is connected to first hidden layer. First hidden layer is connected to what? Second hidden layer. Are you getting my point? Now tell me, what is Z1? Summation of Xi, Wi plus B. We say Wi plus B. What is A1? F of Z1. Are you all clear? Next, what would be Z2? Summation of, not X, summation of A2, W2 plus B. What is the input here for the second hidden layer? A2, the activated output. Atlane kada process. No X తీసుకుంటే what is the need of hidden layer 1, 2, 3 and all that. Hidden layer 2 takes the information from what? Hidden layer 1. What is the output of hidden layer? A2. So what would be W2 now? The output of hidden layer is A1. So what would be W2? Summation of A1, W2 plus B2. A1, W2 plus B2. And then finally we have one output. Are you all clear with this? Okay, let me repeat it again. Okay, if you want you can note it down. What is Z1? Transfer function of the hidden layer 1. So what is the formula for that? Summation of X, W1 plus B1. What is A1? F of Z1. Okay. What is Z2? What is Z2? Summation of A1, W2 plus B2. What is A2? F of Z2. Is it clear? If you want, you can note them down. ఎందుకంటే ప్రోగ్రామింగ్ లో ఇది నోట్ చేసుకుంటే you will understand. Okay. What is Z1? What is A1? What is Z2? What is A2? Are you all clear with this? ఇది అర్థమైతేనే you will understand program and all that. Yes or no? Okay. Yeah. So what are those weights and biases? Please read that point, which is very important. In neural networks, the weights and biases are the fundamental components that significantly influence the model's ability to learn. As I told you, training would be done, teaching would be done with respect to what? The weights. So the model's ability to learn would be improved by what? These weights and bias terms. Okay? And make accurate predictions. Are you all clear with this? Yes or no? Okay? So, these are some terms that we have to understand when I talk about neural networks. Neurons. You all got what are neurons, right? The original information would be processed within these neurons or perceptrons. Okay? What are layers? The neural network are actually organized into the layers. Okay? So, what are weights and biases? Weights and biases are the connections. See, how do we connect? Listen to me very carefully. I have my input layer, I have my hidden layer and then output layer. So the point here is, madam, you told about input layer, hidden layer and output layer, but how are we making the connections? The connections are made with respect to these weights. X1, W1 is connected to the neurons in the hidden layers. Okay. So using weights and biases, what do? We also make connections between each layer, input to hidden 1 to hidden 2, hidden 2 to output and all that. Okay. And then finally we have activation functions that I was talking about. So what is the role of activation functions? Activation functions determine whether a neuron is activated or not, whether the neuron contains information, whether it is activated or not. Are you all clear with this? Yes or no? So when we talk about deep learning or the neural networks, we also have to consider or understand these terms. What are neurons? What are layers? What are weights? What is a bias? And what are the activation functions? Are you all clear with this? Okay. Now, how does the neural network work? So far we have seen what are the components of neural network, how does the neural network looks like. Okay, now let's see how does a neural network work. So idantha ANN. When I'm saying just neural network, it is what? ANN. So in our syllabus we are studying only ANN. CNN cover cheyatledu ikkada. ANN tarvata RNN and all that. If you want CNN lectures, they are available on KMIT Vista channel. Okay, you can just listen for your understanding. Mana syllabus lo ledadi. Okay. So when I talk about neural networks, or what we are doing now is all about what? Artificial neural networks. Okay. Now let's see how ANN works. Okay. So what do you observe in this figure? We have input layer, we have hidden layer, we have output layer. Ikkada varaku telusu manaki. Okay. But apart from that, you can see two more new things. What are they? Feed forward, back propagation. Feed forward, back propagation. Okay. Now let me explain you how neural network works. Okay. Neural networks or ANN works in 3 steps. How many steps? 3. Okay. The first one is the feed forward network or forward propagation. What do we call that as? Forward propagation. And how forward propagation happens? From input layer to hidden layers to output. This is how forward propagation works. ఇంతకుముందు చెప్పాను కదా Z1, A1, Z2, A2, all these are forward propagation steps. Okay, once I forward propagate, I calculate loss, which is step 2. What is step 2? Calculate loss. Again, same thing like machine learning. MSE for regression, binary cross entropy, and categorical cross entropy for classification task. The same thing here again. Okay. So what is step 1? Forward propagation or feed forward network. We call it as forward propagation. Second step, loss calculation. Okay. Now, the concept that is different in machine learning and deep learning is, here in deep learning, as we have neural networks, after we are done with processing and loss calculation, forward processing and loss calculation, if the loss is high, which means accuracy is very low, so we have to go for backward propagation. We have to go for what? Backward propagation. When do we go for backward propagation? When the accuracy is less, that is the loss is high. Now listen what happens in backward propagation. In backward propagation, we adjust the weights. Backward propagation ante supply ki preparation. Okay, we adjust the weights but not inputs like what I told you in the beginning. So we again randomly generate weights, multiply those new weights with the inputs, and then again forward propagate, calculate loss, and check if the loss is reduced or not. Again repeat it. If the loss is still not reduced, I again go for backward propagation, where I again adjust my weights, and then again I go for forward propagation, calculate loss. If the loss is still not improved, is it clear? So the number of times I run this code is called as number of epochs. How many times I run the code is given by this term called as epoch. E-P-O-C-H. So if I say epoch is equal to 10 times forward propagation, loss calculation, backward. Change the weights, forward propagation, backward propagation. Okay, so how many number of epochs we take depends on what? Depends on the loss. Atla okate say 1000 epochs iyudu. Processing time would be more. First give 10 epochs, check the loss. Loss ekkundanko, change the epochs to 20. If still the loss is more, change them. See, more number of epochs and more training is being happening by adjusting the weight such that the model learns. Is that clear? So when we talk about improving the performance of the model, there are 2 parameters which affects model performance. One is by adding number of layers. One is adding what? Number of layers. More number of layers you add, more deep the model learns the data, the loss may be reduced. Maybe the clause here. Okay. Second option in which you can get improved performance is by running it for more number of epochs such that the model gets trained more. Is it clear? So again, these 2 depends on the data. ఇప్పుడు 4 samples data ఇచ్చాను, 4 ఇచ్చాము, 4 ఎన్నిసార్లు చెప్పినా ఫెయిల్ అవుతూనే ఉన్నారు. The data itself is very less. So I don't get good accuracy even if you run for 10,000 epochs, even if you take 10,000 layers. అర్థమవుతుందా? So basically the number of layers will have more understanding about the data. But the clause is what? The data should be more because machine understands only from the data. The more data you give, more complex patterns it identifies and more good the results would be. ఓకే, కొంచెమే డేటా తీసుకొని 1000 లేయర్స్ పెట్టుకొని ఒక 1 crore times epochs రన్ చేసిన ఇట్ ఈస్ ఆఫ్ no use. Is it clear? So just know that adding layers, increasing number of epochs may increase the performance, and all that depends again on what? The quantity or quality of data that we take. Quality ante enti? Manchi pre-process chesi structured data istene again the performance would be improved. If you take raw data, no matter how many number of layers you take, no matter how many epochs you run, you won't get the desired results. ఇట్లా చాలా పారామీటర్స్ ఉంటాయి. ఫర్ నౌ యూ అండర్స్టాండ్ ద ప్రీ ప్రాసెస్డ్ డేటా షుడ్ బి టేకెన్, మోర్ నెంబర్ ఆఫ్ లేయర్స్ విల్ ఆల్సో ఎఫెక్ట్ ద పర్ఫార్మెన్స్. ఐ జస్ట్ సే ఎఫెక్ట్స్ ద పర్ఫార్మెన్స్, ఆర్ మోర్ నెంబర్ ఆఫ్ epochs may or may not affect the performance. All this depends again on what? The size of the data that we take. Is it clear everybody? So how does ANN works? 3 steps. What are they? Forward propagation, loss calculation, backward propagation. So what are we doing in forward propagation? Calculating Z1, calculating A1, calculating Z2, calculating A2. What is Z1? Transfer function of hidden layer 1, which is summation of Wi xi plus B1. What is A1? Activation function applied on Z1. What is Z2? Summation of A1 W2 plus B2. Transfer function of the second hidden layer. What is A2? F of Z2. Activation function applied on Z2. This is all about forward propagation. Loss, we know loss, like how we have calculated for machine learning model, it is the same here. And then backward propagation? Change the weights. So who will do these weights change? Anante, we have optimizers. We have what? Optimizers. We again have different types of optimizers. Gradient descent, Adam, then Adagrad, RMS prop, atla chala untai. The basic or the default optimizer is gradient descent. మనం ఇక్కడ అదే వాడతాం, అది ఎక్స్ప్లెయిన్ చేస్తాను. Is it clear everybody? Okay. So who will update the weights in the backward propagation? Optimizers. So which type of optimizer are we using today? Gradient descent. Gradient. Okay. Yeah. Read this first point. In the first step, what is happening? In step 1, input units are passed, that is the data is passed with some weights attached to it, to the what? To the hidden layer. Okay. So we can have any number of hidden layers. Okay. Now each hidden layer again consists of neurons. All the inputs are connected to what? Each neuron. Ante if suppose I have 60 students in the class, x1 to x60, all these x60 would be connected to the neuron in the hidden layer. Again all this x60 would be connected to the second neuron. Say I have 2 neurons in the hidden layers. I have 60 inputs in the input layer. All these 60 would be connected to the first neuron of the hidden layer. All these 60 would be again connected to the second hidden layer. Is it clear? That is how the connections are made. Next, after passing on all the inputs, the computations would be performed in the hidden layer. Now how are the computations performed? In 2 steps. In what? 2 steps. What is step 1? Z1 is equal to what? W1 into x1 plus W2 into x2 plus W3 into x3 so on plus what? B. Okay, that is called as Z1, and after that Z1 the activation function would be applied to this Z1 which is called as what? A1. Okay. So the whole process is described in point 3 and it is performed in each hidden layer. Okay. Now once it is done, we calculate what? Error. How do we calculate error? The difference between actual value and predicted value. Okay. So after that, if the error is large, the above steps are repeated to minimize the error by using what? Backward propagation. Are you all clear with this? Yes or no? So what are the 3 steps of ANN? Forward propagation, loss calculation, backward propagation. Okay. Now let's see some examples on how ANN works. What do you see here? The input is what? 3 images. 3 images. Okay. So I have 3 images. What are those 3 images? One square, one circle, one triangle. Okay. How many layers I have? 4. How many layers I have? 4. In which there is one input layer, 2 hidden layers, one output layer. Are you all clear with this? How many input layers? 1. How many hidden layers? 2. How many output layers? Okay, this is input layer, these are 2 hidden layers, this is a output layer. Okay, now look at that. What is the size of the image? 28 by 28, that is I have 784 pixels. Okay, so how many input neurons in the input layer? 784, because I have 784 pixels. Okay, so can you see that? X1 to X784. Okay, now what am I doing? First I take input data, which is an image of size 28 by 28. So I have 784 pixels. So in the input layer I am taking 784 neurons. This is first part. Second part, what do? I have to connect these input neurons to what? The hidden layer. Through what? Generating W, generating weights. And that is how the channel is formed. Can you observe that 0.8, 0.2, 0.1? So they are randomly generated weights. You have x1, x2, x3. We have the weights randomly generated. So what do I do next? I calculate what? The transfer function, which is x1 into w1. Akkada chudandi. x1 into 0.8 plus x2 into 0.2 plus x3 into 0.1 and so on. Akkada rende unnai gaani you have to add all x784. Okay, plus what? b1. Is it clear, everybody? After that, what do? I apply activation function. Now, look at the hidden layer neurons. Etla kanipistunnai neurons hidden layer lo? Anni black unnai. Yes or no? After I apply activation function, hidden layer neurons emaindi? Konni yellow unnai, konni black unnai. What do you mean by that? Few neurons are activated. ఇప్పుడు నేను క్లాస్ చెప్పిన అందరికి అర్థం కాదుగా, అర్థమైనోడు యాక్టివేట్ అయినట్టు. Yes or no? So, after I apply my activation functions, what's happening? Observe the neurons in the hidden layer. There are few yellow neurons. Those neurons are activated and they are processing the data. They have understood and they are processing the data. Now again I connect between what? The first hidden layer to the second hidden layer by adding what? By generating what? Some random waves. Okay. Now observe the second hidden layer. Malli yellow circles kanipistunaya? That is because I have applied activation functions on that. And after that, I generate the output. What is the image actually? Circle. Kani ye image? 3 images unnai kabatti what type of task is this? Multi-class classification. So how many output neurons? 3. Because I have 3 images kada? Circle, square, rectangle. Andukane 3 neurons తీసుకున్నాం in the output layer. Okay. Now look at that. The input image is what? A circle. But what is the output that is given? Square. Now look at the values in the output. Look at the values in the output. 0.5, 0.4, 0.1. 0.5, 0.4, 0.1. Probability values vachinayi. Saying that it 50% this might be a circle, 40% this might be a square. Atla vachindi. So what is the answer as per the prediction? Square. But what is the actual image? Circle. So 50% loss. 50% is the loss. And accuracy is only 50. So will you say that okay, your super job, you have done super job and odlestar akkada? So what do we have to do? The output is wrong. We have to go for what? Backward propagation. So what do I do in backward propagation? Look at the weights here. Ikkada weights em unnai? 0.8, 0.2. Now look at the weights here. 0.9, 0.7. So in backward propagation, what am I doing? x1, x2 ni change chesana? x1, x2 are the same, but I am changing what? My weights. And then again I calculate and now I check the output. Student output ఇప్పుడు ఏమొచ్చింది? Circle. Why am I calling the output a circle? First దానికి 0.04, Circle ki 0.9, triangle ki 0.06. So which output has good prediction? Circle. So I say what? The model is performing well. So I don't go for backward propagation again. So in 2 epochs, my processing has been done. Is it clear, everybody? Yes or no? So this is how ANN works. Forward propagation, loss calculation, backward propagation. In forward propagation, what do we do? Take input, randomly generate weights, add the bias term, do the same, apply activation function to that, do the same thing again for a number of layers. Second step, calculate loss. Third step, backward propagation. Is it clear, everybody? The same thing. Okay. So this previous example was what? Multi-class classification. Now here this is a binary class. Why am I calling this as binary class? Take a leaf and say whether it is a diseased leaf or not diseased leaf. Okay. Look at that. So how many neurons I have taken in the output layer? 2. Okay. How many neurons in the input layer do I have to actually take? The size of the image is 4. Random representation. My question is how many do I have to take? Size of the image is 30 by 30. 900. So how many input neurons? 900. That's a rough figure. That's why you say 4 antunar meeru. Huh? So how many neurons do I have to take in the input layer here? 900. How many neurons do I take in the output layer? 2. One for what? Disease leaf. One for not. If I take it like this, disease leaf vachindu input. Our disease leaf ki output would be 1. The remaining output would be 0. If I take non-diseased leaf, diseased ki 0 ostadi, non-diseased ki 1 ostadi. So you can either take 2 neurons, I can just take 1. Disease leaf which nanko 1 output, activate that or don't activate that. That depends on how we design. Okay. Same thing again. Input to hidden. Hidden to what? Second hidden layer, third hidden layer, and then finally calculate the outputs. Okay. So what type of leaf did I take in the input? Non-diseased. But the prediction is more for what? Disease. So is this correct? So what do I do? Backward propagation. Okay. I go for backward propagation until and unless I get my correct output. Okay. Now, multi-class classification again. Okay, there's a data set called as MNIST. Okay, handwritten digit classification. Any digits unnai manaki? 0 to 9, 10 digits. Okay, so how many output neurons do I take? 10, 1 for each class. 0, 1, 2, 3. So if I give 7 as input, which neuron should be activated at the output? The 7. Okay, so input layer, hidden layer, output layer. Okay, so if I take 9, 9 should be the output. If I take 2, 2 should be the output. So what is the size of this image? 784. So how many neurons do I have to take in the input layer? 784. Okay, so these are the number of neuron layers and I take the output. Okay, now as I told you, why more number of layers? What did I tell you when you take more number of layers? We said more deep the image would be processed or more understand. Let's see how does that happen. Look at that 9. If I take 2 layers, how will the 9 be processed? A circle oka layer processes neatly. The diagonal standing line would be processed by 1 layer. Part ga individual ga it will be processed in depth. Okay. So when I go for more number of layers, if I add 5 layers, 0 netla process chestundi 5? One part. So that when you write 0 in different way, in that way, in this, sometimes 0 ni circle full jayam. Ekkado oka దగ్గర మా అమ్మ ఎట్లా చేస్తుంది? She don't circle it completely. You laga rasadi 0 ni. Okay, in that case, if you add only 1 hidden layer, round mottam process aitundi, so it says this is not 0. But if you divide it into parts and process, a circle shape, proper shape lekunna it identifies because I am processing my image into different shapes. Are you clear? So adding more number of hidden layers will actually help us in understanding the patterns in the data more deeply. Okay. So this is the entire architecture of ANN. So what are we doing? Forward propagation, loss calculation, backward propagation. In backward propagation we are using what? Optimizers which will actually update the weights. Okay. So what are we doing in forward propagation? Multiplying weights with what? Multiplying inputs by weights, adding biases, and applying the activation function. Okay. Now let's see activation functions. All of us are clear with forward propagation, right? How many of you are clear with forward propagation? Okay, good. So there is something that we have to learn when we talk about forward propagation, which is what? Activation function. Because the main functionality is being done here. Yes or no? So one functionality is adding random weights to the inputs, which is done by a random function. But the originality of the model or the functionality of the model lies in choosing these what? Activation functions. So now let's understand what are these activation functions, how many types of activation functions we have, and then which activation function to be used when and all that. Okay. Now, what are activation functions? What do you see there? Activation, as I told you, activation functions are used to activate the neurons. But how does they activate neurons is what we will see now. Okay. So activation functions are crucial in neural networks because they introduce non-linearity to the model. What do you mean by introducing non-linearity? They make the model understand the underlying patterns of the data such that if they understand the data, they will be activated or they will not be activated. Okay. So just understand the non-linearity in the model would be introduced by using what? The activation functions. Okay. Enabling the network to learn complex patterns within the data. Okay. So without activation functions, the neural network would be what? Simple linear regression. Data తీసుకొని pass చేసి it's like machine learning model again. Taking the data, ఎంత వెయిట్ చేసినా ఏది చేసినా you're just passing it directly. No, there's no change in the neurons that is being happening. So without activation functions, the model would be acting just like a simple machine learning. Brain is there, but the brain is what? Dead. So can you do anything without that? Okay. Activation functions are the crucial thing that we have to do when we talk about what? Machine learning, artificial neural network processing. Okay. So there are 4 activation functions which we use. How many? 4. Okay. Make a note of it. First one is called as sigmoid. First one is called as sigmoid. Okay. Just write sigmoid. Listen to me. After that you can write what is that sigmoid. Okay. We can use sigmoid in the hidden layer and also the output layer. Okay. Don't write anything. Just listen. Just write sigmoid. Ante oka word rayandi ante. Okay. We can use sigmoid in the hidden layer and in the output layer. But we use sigmoid only. We prefer using sigmoid in the output layer. Adi endukane tarvata you'll understand. But just for now, as this is your first session, just understand. Sigmoid would be used in the what? Output layer activation function. Okay. Now, first point is what? We use sigmoid in the output layer. In the output layer also again, for binary classification, we use sigmoid in the output layer. Adokka point raskondi. Sigmoid is used in the output layer for binary classification task. Sigmoid is used in the output layers for binary classification task. Okay. ఇప్పుడు leaf disease detection is which type of task? Binary. So which activation function do we use in the output layer? Sigmoid. Adhamaina? Sigmoid is used in the output layer for binary classification. Okay. Next. Tan H is used in the hidden layers for any task. Tan H is used in the hidden layer for any task. Tan H is used in the hidden layer for any task. Okay. Next, ReLU, R-E-L-U, rectified linear unit. ReLU is again used in the hidden layer for any task. ReLU is used in the hidden layers for any task. ReLU is used in the hidden layer for any task. Lastly, we have softmax. Softmax, write down. Softmax is used in the output layer for multi-class classification task. Softmax is used in the 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 hidden layer for multi-class classification task. Output layer for multi-class classification task. Okay? That's all. ఇప్పుడు మీకు ఒక క్వశ్చన్ రావాలి. I'll wait for that question. Huh? No. No. There should be a question that there's a question that should be raised when you see those 4 points. Huh? Input layer we don't apply neurons. Input is just for processing we apply new activation functions only in the output and hidden layers. Okay? Observe and tell me I'll wait. Even if it is for 10 minutes, I'll wait. Very good. Who told that? I appreciate you. Okay? I mentioned about activation functions for binary class, multi-class. But did I specify about activation function for regression? In the output, if it is binary, I said we use sigmoid. If it is multi-class, I said we use what? Softmax. But what is the output for regression? Okay. Now listen, why do we use sigmoid? Why do we use softmax? Please listen to me very carefully. Sigmoid will take any continuous values and adjust those values between 0 or 1. Ante, for example, if all of you have different CGPAs, right? I'm not bothered about your CGPA. I just want to know if you are pass or fail. Because if you are fail, I don't think you'll understand anything here. A basic subject rakapothe idu ardham kaadu. So I don't want your CGPA percentages. But I want to divide the CGPA percentage. I'll take your CGPA as input. But looking at your CGPA, I'll say 0.5 above and below. 0.5 above CGPA, yes, you are in. 0.5 below CGPA, you are out. So though I am taking different CGPA, that is continuous values, but I want my classification to be done yes or no, 0 and 1. So that is done by sigmoid. So sigmoid will adjust all range of values to 0 or 1 by putting a threshold. Okay, so andukane for binary classification task we use what? Sigmoid. Iki a value vachina gaani you will put a threshold. Above that value it is 0, below that value it is what? 1. Okay. Now when I talk about softmax, softmax will predict the probability. అందుకని ఇంతకు ముందు ట్రయాంగిల్ రెక్టాంగిల్ 0.9, 0.4, 0.1 percentage, that is probability. So why did I take those probability? Because I have multiple classes. So when you have multi-class classification, I can't directly say this is triangle, this is rectangle. 90% it may be triangle, 90% it may be rectangle. So I'll give the probability of the class. I'll give the probability of the class. I'll tell you a very good example. Please listen to me. Handwritten digit recognition only. That is which type of task? Multi-class classification. Why? I have 10 digits to be classified. Okay. Let's consider number 7. 7 etla untadi? One sleeping line, one standing line. I write very small dot sleeping line. I write big standing line, which usually appears like 1. Which usually appears like what? 1. Because ఆ పైన నేను చాలా చిన్నగా పెట్టి ఓన్లీ ఇది ఒక్కటి పెద్దగా పెట్టిన. యూజువల్గా వెన్ ఐ ట్రైన్ ద మోడల్ ఇది ఈక్వల్గా ఉంటే ఇది 7 అంటాను. లేకపోతే అట్లీస్ట్ దిస్ షుడ్ బి 50% ఆఫ్ వాట్ ఐ డ్రా దిస్. దిస్ ఇస్ హౌ ద నంబర్ ఈస్ యాక్చువల్లీ దేర్. బట్ ఇఫ్ ఐ పుట్ జస్ట్ అ డాట్ అండ్ గివ్ అ బిగ్ లైన్, it may not assume it to be what? 7. So I say the probability that this may be 7 is only 20%. Yes or no? So I am not exactly saying this is not 7, this is 7. But I am saying it as what? Probability of the image that may be 7. I'll give you another example. These days అన్ని హైబ్రిడ్ మోడ్లు వచ్చి కొన్ని క్యాట్లు డాగ్ లాగా కనబడతాయి, కొన్ని డాగ్లు క్యాట్ లాగా కనబడుతున్నాయి. ఎస్ ఆర్ నో? Suppose if I take a side angle or a dog peeping through a wall, okay, or the backside, the reflection of that in the sunset or in the beach or something like that, okay, akkada konni shapes cat dog la ganabadtadi, dog what, cat la ganabadtadi. So in this case what do? I give the probability of prediction. So that probability of prediction would be given by which activation function? Softmax. Andukane we use softmax for what? Multi-class classification. Is that clear, guys? So which activation function for binary classification at the output? Sigmoid. Which activation function for multi-class classification? Softmax. Reasons చెప్పేసాను. Now when it comes for regression అంటే ఏంటి? కంటిన్యూస్గా ఐ డోంట్ వాంట్ 0 or 1. వెదర్ ప్రిడిక్షన్ ఎంత అంటే 0 1 అని చెప్తూ ఊరుకుంటారా? I want continuous values. Today's weather is 18 degrees Celsius. అట్లా కంటిన్యూస్గా after 1 hour it would be 19. I want continuous values. So I will not use any activation function only if it is a regression task. We will not be using any activation functions in the output if it is a regression task. Are you all clear? And I was just talking about activation functions in the output. So if it is regression, no activation function. If it is binary classification, sigmoid. If it is multi-class classification, softmax. Are you all clear with this? Yes or no? Okay. Now let's get back to hidden layer. Which activation function for the hidden layer? You can use any of them, but we prefer ReLU. But we prefer what? ReLU, sometimes TANH, but most probably we use what? ReLU. Are you all clear with this? Yes or no? Why ReLU ante? Now listen, look at that ReLU. ReLU introduces non-linearity. This is what we want, right? ReLU introduces non-linearity by outputting the input directly. If the input has some information, it gives the input directly to the output. That is what I want. I want to take the input as it is and apply activation function and check if that has real data or not. Okay. So ReLU will actually be used in the hidden layers. Adi regression gaani, classification gaani, edaina gaani. So in the hidden layers we use what? ReLU. So in the output layer again, depending on task, we'll change it. For regression, no. For binary, sigmoid. For multi-class, are you all clear with this? Yes or no? So with this we are done with theoretical session. Okay. So take a break for 10 minutes. Come back. We'll work on one hands-on session. Okay, sample hands-on session ikkada chesdamu like last time. After this, rape exercise lab lo malli you have to do on hands-on. 3 hours untadi ikkada 1.5 hour lo I'll just explain. Tomorrow you have to sit in the lab and do the same. Vere data set verega istamu, the same model. Is it clear? Okay. 1 by 1 plus e power minus x. Only this is what we require. Okay. Now, what is tan h? What is the difference between sigmoid and tan h? Is listen to me. So in sigmoid, I take values between 0 to 1, as you can see in the previous definition. Tan h will take range from minus 1 to 1. Sigmoid will take what? Only the positive values 0 to 1, whereas tan h will take from range minus 1 to 1. So for sigmoid, we have 1 by 1 plus e power minus x. For tan h, we have e power x minus e power minus x divided by e power x plus e power minus x. The entire range, positive and negative of all the, okay? Okay, don't worry about it. Okay, now what is ReLU? As I told you, it introduces non-linearity, produces the input as it is if the input is a positive value. If input is 0, it will produce what? 0 as the output. So the formula for ReLU is, please note it down, f of x is equal to max of 0 comma x. F of x is equal to max of 0 comma x. What is max of 0 comma x? It is x itself. Okay, if x is 0, the output would be 0. Other than that, if x is a positive value, the output would be a, okay. So that is the reason I want to pass all my input as it is, introducing non-linearity. We use this activation function called ReLU in the hidden layer. Okay. Next, again we have variations of ReLU as I was telling, Rekey ReLU and all that. We'll discuss about that later in depth. Okay. So for binary classification, we use sigmoid. Then how about multi-class classification? So In multi-class classification, we'll be using this what? Softmax function, which will give us what? The probabilities. Okay. Will give us what? The probability by this calculation. So it is 7, 0.513. The probability that it is 7 is 0.97. The other values are less. Okay. So this is all about what? The softmax function. For linear regression, there is no activation function that we use in the output layer because the values should be taken continuously and as they are. I don't want 0 or 1 classification, or I don't want probability of the original value. So we don't use any activation function when we talk about what? Regression. Okay. So this is all about the forward propagation. Okay, so we are done with forward propagation. What do we do in forward propagation? Transfer function calculation, activation. We also seen what are different activation functions. Now let's quickly recap loss. So what is loss function? Actual value minus predicted value. That will give us how well the model is performing. Okay. So the loss function is a measure of how well the neural network's predictions match the actual results. So what are the common loss functions? Mean square error, which we use for what? Regression. Cross entropy, which we use for classification. Again in cross entropy we have binary cross entropy for binary class, categorical cross entropy for multi-class. Okay. So this is a model and that is how we calculate the loss. Actual value minus predicted value. The actual value are y test. The predicted values are y prediction. Okay. What is cost function? Loss is for one sample. అంటే ఈ ఒక్క స్టూడెంట్ నేను చెప్పింది అర్థమైందా లేదా అనేది లాస్ ఫంక్షన్. But I want overall, I don't want student by student. I want to know overall if all the students have understood or not. So I'll take a mean of it. So that is called as cost function. For one sample, error calculation is called loss function. The average value of error of all the students is called as what? Cost function. Okay, look at that. When we refer to the error of a single training sample, we call it as what? Loss. The average of all the losses of all the samples is called as what? Cost function. Okay. So for regression it is MSE or MAE. Okay. Now look at this. This is a regression task. What do you mean by regression task? Continuous value prediction. Okay. These are the actual data points. These are the actual data points and we draw a regression line. We draw a regression line which is Y prediction. Those data points are Y train and Y test. That line is what? Y predicted line. Now what you observe there? Few dots are above the line, few dots are below the line. Above the line in the sense, the prediction is less. The actual point is more, the prediction is less. If the dots are below the line, what does that mean? The prediction is more but the actual value is less. So I am drawing a red line between that dot and that blue line. That line is nothing but your loss. That blue line is the actual value. Sorry, blue dot is the actual value. Blue line is the predicted value. The difference between that actual and predicted is nothing but the loss. Is it clear? Why do we take MSE? Is because the loss is sometimes high, the loss is sometimes low. Low ఉన్నప్పుడు మనకి నెగటివ్ వాల్యూ వస్తుంది లాస్. అది రిమూవ్ చేయడానికి స్క్వేర్ పెడతాం. స్క్వేర్ చేస్తే ఏమవుతుంది? The negative value would be converted. What is other alternative for other than square? Absolute value. Absolute value అంటే ఏంటి? Absolute of -2 is equal to what? +2. So that is the reason we take squaring or the absolute when we talk about what? Loss calculation. Why do we take absolute mean square error or mean absolute error? Because when we are trying to predict the value, the predicted value may be more than the value, more than the actual value or less. So when it is more than the actual value, we get negative values. In order to remove that, we go for MSE calculation or MAE calculation. Is it clear everybody? So what is the formula for MSE? 1 by n. What is n? The average of the samples into summation of y minus y cap. Y is the actual values, y cap is the predicted values, whole square. Okay. For classification, what laws do we use? For binary classification, we use binary cross entropy. For multi-class, we use categorical cross entropy. Okay. So for classification, we are predicting the probability if it is multi-class. So we'll have to go for probability of that particular class. Okay. When it is binary classification, please note down. What do we use in the output? Sigmoid activation function. Similarly, you have to calculate the loss with respect to the sigmoid, right? After activation function only, we'll calculate loss. So we'll have to calculate the loss. So this is the formula for loss. Please note it down. Loss is equal to BCE. For binary cross entropy, the loss is equal to, write down the formula. For binary cross entropy, the loss is equal to Y into minus log of Y prediction, Y into minus log of Y prediction plus 1 minus Y into minus log of 1 minus Y prediction. Y into minus log of Y prediction plus 1 minus Y into 1 minus Y prediction. What is this? And I'll explain you. Listen to me. Did you write the formula? MSc formula raskunara? 1 by n summation of Y minus Y prediction whole square. This is for what? Binary cross entropy. Okay. Now see this. So when I say about binary cross entropy, I have two categories. What are they? 1 or 0. Yes or no. True or false. So we call it as positive class, negative class. So I have to calculate positive class, which is called as y is equal to 1. I have to calculate negative class, which is called y is equal to 0. Now look at the truth table kind of thing. I have y and y prediction. What is y? The actual value. What is y prediction? The predicted value. If suppose I have actual as 1, predicted also 1, which means what? Correct prediction. So our loss would be what? 0. Because actual is 1, prediction is also 1. So there is no loss. Machine has predicted correctly. So accuracy is 100. So loss would be 0. For second case, actual is 1, y is 1, but machine has predicted is what? 0. So what will happen in this case? The loss should be high, which means accuracy is 0. Second case, actual input is 0, but the machine has predicted as what? 1, which is again loss is high. Last case, actual is 0, machine also has predicted as what? 0. So the loss is 0. So I want this type of output. Do you all agree? Y and Y prediction chudandi. 1 1 unte enti? The actual value is 1, machine also predicted 1. Hence there is no loss. Machine has done its job perfectly. No loss. For 0 0, same, no loss. But for if the input is 1, machine has predicted 0. Or if the input 0, machine has predicted 1, the loss should be high. For that reason, we write this formula like this. One case for remains when y is equal to 1, removed when y is equal to 0. The first part. Second part, remains when y is equal to 0 because it is 1 minus y. It will be removed when y is equal to 1. Either that class or this class. That is the reason this is the formula for BCE. What is the formula for BCE? Y of minus of log of y prediction plus 1 minus y into minus log of 1 minus y prediction. Is that clear, everybody? Did you understand this formula? Okay. Next, for multi-class classification, we have to take the probability of all the instances. Okay. For which we write e power yi by summation of all the samples. One sample by all the samples. Ardhamautunda probability etla? One sample by all the samples. So e power yi by summation of I is equal to 0 to 1 e power yi. That's all. Endukante when you are programming, you will need these formulas. Are three formulas chalu. MSE, BCE, CCE. This is called CCE, categorical cross entropy, which we use for multi-class classification. E power yi by summation of I is equal to 1 to 0 e power yi. Probability 1 by, see, 60 students unnaru, 100 students unnaru. 10 by 100 ante enti? 10 pass people out of 100. This is the probability. So the same thing here. Okay. Now this is called as what? Categorical cross entropy. Okay. So for binary, look at that. For binary classification, we use which activation layer? Sigmoid. And we use tan H for the hidden layers. For multi-class classification, for hidden layer we use Rayleigh's tan H. It is common. But in the output layer we use what? Softmax. That is what I told you, right? Binary, hidden layers lo annitlo railway. But output layer lo for binary class we use sigmoid, for multi class we use what? Softmax. Idi okkati gurtu pettukondi. Okay? So now let's get back to backward propagation. Rendu అయిపోయినాయి. ఏంటది? Forward అయిపోయింది, loss అయిపోయింది. Now let's come back to the most important part, which is what? Backward propagation. Okay? Now, what is backward propagation? Changing the weights. Adjusting. We don't call change, we adjust the weights to reduce what? Loss. Okay? How are we adjusting the weights? By using what? Optimizers. By using what? Optimizers. Okay? Now, what does optimizers do? How does optimizers change the weights? Ante by calculating the derivatives. By calculating the derivatives. So this is all about gradient descent. I told you, right? One type of optimizer which is called what? Gradient descent. Now let me tell you what does gradient descent do. Gradient backward propagation antene the name itself is backside nunchi ostadi. How are you doing forward propagation? Input to hidden, W1, B1, W2, B2, Z1, A1, Z2, A2 calculations. Yes or no? But backward propagation etla avutadi? Z2, A2, Z2, A1, Z1. This is how the backward propagation happens. So we will calculate derivatives of all this. We will calculate what? Derivatives of all this. 5 derivative calculations untai. Listen to me now. Output derivative calculation okati. What is that? Output derivative calculation. దాని తర్వాత W2, B2 derivative calculations. W2, B2. దాని తర్వాత A1, W1, B1. A2, W2, B2, derivative of A1, derivative of W1 and B1. అర్థమవుతుందా? Derivative of A2, derivative of W2, B2. Weights కూడా చేంజ్ చేయాలి కదా. So weight, I am changing the weights of the second layer, bias of the second layer. I am changing the derivative of A1. I am changing the derivative of W1, B1. అక్కడ A2 calculation, derivative of that. W2, B2, derivatives of this. A1 calculation, derivatives of this. Z1 calculation, A1 calculation and W1, B1 calculations. కొంచెం కన్ఫ్యూజింగ్గా ఉంటుంది, ప్రోగ్రామింగ్ అప్పుడు ఈజీగా అర్థమవుతుంది. జస్ట్ అండర్స్టాండ్ దాట్ బ్యాక్వర్డ్ ప్రాపగేషన్ అంటే ఆప్టిమైజర్స్ విల్ అడ్జస్ట్ ద వెయిట్స్ బై క్యాలిక్యులేటింగ్ వాట్? ద డెరివేటివ్స్. హౌ ద డెరివేటివ్స్ విల్ ఎక్స్ప్లెయిన్ యూ ఇన్ డీటెయిల్. ఓకే, ఇక్కడ చూడండి. సో ఎల్ ఈజ్ లాస్. ఎల్ ఈజ్ వాట్? లాస్. ఆ లాస్ ఎక్కడి నుంచి వస్తుంది? ఫ్రమ్ జెడ్ ఆర్ A2. సో ఐల్ క్యాలిక్యులేట్ డిఎల్ బై డిజెడ్. ఐల్ క్యాలిక్యులేట్ వాట్? డిఎల్ బై డిజెడ్. అంటే మన కేసులో డిఎల్ బై డిఏ2. డిఎల్ బై డిఏ2. ద లాస్ విత్ రెస్పెక్ట్ టు ద ప్రీవియస్ కేస్. అంటే ఏంటి అని అంటే, లిసన్, ఐల్ ఎక్స్ప్లెయిన్ యూ వై డస్ దిస్ హ్యాపెన్. దిస్ పర్సన్ హెస్ ఫెయిల్డ్. నౌ ఐ హ్యావ్ టు అడ్జస్ట్ ద వెయిట్స్. సో ఐల్ చెక్ ఈ మెథడ్ ఈ పర్సన్కి ఈ టీచింగ్ మెథడాలజీలో వర్క్ అవుతుందా, ఇంకో అంటే థియరీగా చెప్తే వర్కౌట్ అవుతుందా, సో ఐఎమ్ మేకింగ్ సమ్ ప్రాబబిలిటీస్ బై క్యాలిక్యులేటింగ్ దీస్ డెరివేటివ్స్. సో derivative of z with respect to A2, okay, and then derivative of W2 and B2, because ఈ W2 B2 వల్లనే కదా నాకు Z2 calculate అయింది. Yes or no? I am calculating Z2 with respect to what? These weights and biases. So I'll change this also, and then I'll change A1, and then I'll change W1 B1. By calculating all these derivatives, the weights would be updated. Is it clear everybody? Yes or no? కొంచెం ఉంటుంది, that's okay. Okay, look at that. X is what? The input. What is that? W1? The weights that are added along with this. So in the hidden layer, what do we calculate? Z1, A1. What is Z1? Summation of Xi, Wi plus P. What is A1? F of Z1. Now what is W2 here? The weights that are being generated, which will give the connection between what? Madam, ఇక్కడ సెకండ్ హిడెన్ లేయర్ లేదు కదా. వై ఆర్ వి క్యాలిక్యులేటింగ్ W2 అంటే, ఫర్ కనెక్టింగ్ ద ఫస్ట్ హిడెన్ లేయర్ టు ద అవుట్పుట్ లేయర్ వి రిక్వైర్ సమ్ వెయిట్స్. ఇస్ ఇట్ క్లియర్? సో దట్ ఈస్ W2. సో ఫైనలీ వాట్ డు ఐ క్యాలిక్యులేట్? Z2 or A2, which is the final output. Is it clear everybody? Yes or no? So these are the terms that you have to understand. W1, the weights from input to hidden. W2, the weights which connects hidden to output. Z1 A1, the transfer function activation function of the hidden layer. Z2 A2, the transfer function and activation function of the output layer. Is that clear, everybody? Yes or no? This is the most important diagram which will depict all the terms. Okay? Yes. Okay, what is Z1? W1 x plus B. What is A1? F of అన్న ఇప్పుడు F అనొద్దు మీరు అప్పుడు F అంటే ఫంక్షన్ ఏదో తెలియదు కాబట్టి అన్నారు. So what is which function we use in hidden layers? ReLU. So what is A1? ReLU of Z1. What is Z2? W2 into A1 plus B1. What is A2? Sigmoid or softmax depending upon what class we take. Is that clear, everybody? అర్థమైందా ఇప్పుడు? Write those things. Z1 is equal to summation of W1x plus B. W1x plus B. What is A1? ReLU of Z1. Why ReLU? Because hidden layer. What is Z2? Summation of A1 into W2 plus B2. Okay. What is B2? Sorry. What is A2? Sigmoid of Z2. What is the loss here? A2 is the predicted one. Y is the actual one. A2 is what? The final output which is predicted. Y is the actual loss. Okay. Look at this. B1, B2, biases, ReLU of that one, sigmoid of that one, and then finally we calculate what? Loss. Backward propagation. So what are we doing? What are the two things that we are doing in backward propagation? Computing the gradient of the loss function with respect to each weight using chain rule. Chain rule and back by back. Step by step we are calculating the gradients. Okay. So what rule is used in calculating the gradients in backward propagation? Chain rule. So what do? We adjust weights and biases such that we minimize the loss function. Okay. So backward propagation is the process of what? Updating and finding the optimal values of weights which help the model to minimize the error. That is the difference between the actual value and the predicted value. How the weights are updated? Using what? The weights are updated using what? Optimizers. What are optimizers? They are the methods or mathematical formulation which are used for changing the attributes of the neural networks. Here when I talk about attributes, it is nothing but the weights. Okay. Backward propagation with respect to what? Gradient descent optimizer. Okay. In the deep yeah. Wx is the original weight, first weight. I am updating that particular weight with respect to a small parameter which is called as learning rate. అంటే పాత weight కి కొత్త weight కి difference కూడా తెలియాలి కదా, అది అప్డేట్ అయిందా లేదా అని. So we introduce one parameter which is called as what? Learning rate. So W is equal to, write down, update the parameters by W is equal to W minus A. W is equal to W minus A. That A is called as learning rate. That A is called as what? Learning rate. ఒక small value 0.01. ఉండి లేనట్టు ఉండాలి, కానీ that should make the difference between the old W, new W. What do you write? W is equal to W minus A, right? The first W is the new weight. Second W is nothing but the old weight. Okay. So W is equal to Wx into A. Okay. So this is all about what? What are neural networks? So what did we study so far? What are neural networks? How many types of neural networks? In that first type of neural network, which is what? ANN. So what are the three steps in which ANN works? Forward, loss, backward. Okay. Are you all okay with how forward is happening? How loss is calculated? Loss 3 formulas. 4 activation functions of forward and backward. Okay. Now shall we get back to the program? Okay. Now before we get back to the program, what were the steps that we have used for developing a machine learning model? Take the import libraries, read the data set, pre-process the data set if it is required, train the model using .fit, test the model by using .predict, and then evaluate the model by using performance metrics. Yes or no? Did we do anything else other than this? But here in this case, we have more steps. Why? Forward, loss, backward. It takes more steps. Let's see what are the steps. Don't write, not required. Okay, just you listen, you'll understand. What is step 1? Same. Import the libraries, load the data set. Don't read that matter, just understand. We'll import the libraries and read the data set. Second, what is the need for splitting the data? Because ANN models deal with what? ANN models deal with huge data. So obviously we have to split the data into train data and test data. So after we load the data, we divide the data into train and test. How do we do train and test splitting? There's a function called what? Train underscore test underscore split. From where do we take this? sklearn dot model selection. From sklearn dot model selection, we import the function train underscore test underscore split. Same thing like what we have done there, we do the same thing here, there's no change. Okay. Next, step 3 is what? Normalizing the features. I explained about standardization, right? So there are 2 things that you do on the input. Output మీద చేయము ఇది, only input మీద చేస్తాం. Okay. So standardization is, as I told you in the last session, when I have a data set, 3 input, చెప్పండి, attendance percentage, marks CGPA and curricular activity participation. Expecting CGPA based on your attendance, previous year CGPA and your co-curricular participation. So attendance will have range from 0 to 100, CGPA will have range from 0 to 10, your participation will have either 0 or 1. Which means all 3 are equally important for me to understand if we'll clear this exam or not. All 3 have their different importance. But machine thinks attendance is very important because they have big values. Okay. So we have to normalize these values or we have to standardize these values such that the machine will understand that all the values are of equal importance. Okay. So we calculate the mean, standard deviation, variance, and so by all these we have standardization. Okay. So we have to normalize the features because we are dealing with huge data. Machine learning and chinna models we didn't do that there. But when you are doing deep learning models, this is a mandate step. What is that? Normalizing the values or standardization. I'll tell you what is normalization. If suppose I have one column where I say, let's talk about a data set about, the age. He writes 19. He writes NINETEEN. What is the difference here? The age character asaru, but representation is different. So I put either that standard or this standard. Okay, this is called normalization. Standardization is making machine understand that all the features have equal importance by adjusting those values. Okay, so we'll see how to do standardization, normalization. Don't worry about it, but just understand that this is one of the most important pre-processing steps when we work on with what? Deep learning models. Next, initialize ANN parameters. What is step 4? Initialize ANN parameters ante W1, B1, W2, B2. Is it clear everybody? Initializing weights ante enti W1, B1, W2, B2 such that the architecture would be formed. What is W1? Connection between input to hidden. What is W2? Connection between hidden to output. So I am forming the network architecture by initializing the parameters W1, B1, W2 and B2. After that, I'll define the activation functions. Depending on the problem statement that you receive, we have to define the activation functions. Anni activation functions avasram ledu. If suppose I give you breast cancer prediction. Whether the female has breast cancer, yes or no. So what type of problem statement is this? Binary class. So which activation functions you want? Sigmoid for output ReLU for hidden. So R&D define చేయాలి. Is it clear? If I say identify the digit, what type of task is that? Multi-class. So what activation functions we define? Softmax and ReLU. Normalize the values. Normalization or standardization, pre-processing of the input features. Step 4, initializing the parameters. What do you mean by initializing the parameters? Making the network architecture. Initializing W1, B1, W2 and B2. Next step, define activation functions. After that, forward propagation. After that, loss calculation. After that, backpropagation. And then finally, training, update the parameters, train the model. Train the model for a number of epochs. After that, evaluate the model and start making predictions. Are you all clear with this? Or shall we get back to the exercise? The exercise here is very interesting. Okay. So we have half an hour time. We have to complete the exercise within this. Yeah. So I have 2 exercises for you today. Okay. One is developing a deep learning model using libraries. One is what? Developing deep learning, same ANN model using what? Library. Second, ANN model using Scratch. Scratch ante forward, backward avanni. And the reason why is you should know that there are something called libraries and the functions which are already defined, and we can use them and develop the model very simple, which is very simple. But you will not understand what is happening inside if you use that model. Nina decision tree classify చేశారు. Yes or no? Lab లో ఏ algorithm చేశారు? Random forest. You have known how to develop the model, but did you understand how random forest works? అర్థమవుతుందా? We have worked on decision tree classifier. Yes or no? Forget about your lab. On day 1, what did I teach you? Machine learning model, which is what? Decision tree classifier. Did you learn how to develop the model? Yes. But did you actually understand how decision tree works? Exactly no. Because we have just used the function. What is that function? Decision tree classifier. అది పెట్టి X train, Y train అని ఇచ్చేసాం, అయిపోయింది కథ. Yes or no? So, but we doesn't know what exactly happens internally. Which layer is taken as what, what are the leaf nodes, what are the root nodes, and all that is not considered. That is very simple, but we will not understand what exactly is happening. So, after this theory session, did you understand how ANN works from scratch? Yes or no? But I'll tell you one model now, the basic deep learning model. Tell me if you will understand ANN working with that model or not. Okay, let's get back to the exercise. Okay, so we have seen machine learning model yesterday. So we have imported the libraries. Okay, and then we have loaded the data set, a simple data set. Okay, and then we extract the features X and Y, and then we created a data frame out of that. We divide the data into what? Training data, test data, and then we have directly used what? Decision tree classifier. Without knowing how decision tree works, we have directly used what? Decision tree classifier. Okay, and then we have trained the model using dot fit. We made the predictions using dot predict function on X test, and then we have directly evaluated the model using accuracy parameter. Okay, so this is what we have done. What? In the last session. Okay, so let's see how deep learning model is developed in this way without the libraries. Okay, or with libraries. Let's see how deep learning model is developed. Okay, so first we import the libraries. What are the libraries that I'm using here, guys? I'm using pandas for data pre-processing, for loading the data and all that. Next, from sklearn.datasets, I'm importing one data which is called what? Load breast cancer. From sklearn.model selection, I'm importing what? Train test split. From sklearn.preprocessing, I'm importing what? Standard scalar for normalization of the data or standardizing the features. From sklearn.metrics, I'm importing what? Accuracy. Here I'm using new library. What is that library? TensorFlow for deep learning models. sklearn for machine learning models. TensorFlow for deep learning models. So as I'm working on a deep learning model, I'm importing what? TensorFlow as what? TF. In TensorFlow, again I'm importing a model called sequential. From tensorflow.keras.models, I am importing what? Sequential. Now listen to me very carefully. మెషిన్ లెర్నింగ్లో చాలా డిఫరెంట్ అల్గారిథమ్స్ ఉన్నాయి. డెసిషన్ ట్రీ క్లాసిఫైయర్, ర్యాండమ్ ఫారెస్ట్, నేవీ బేస్. సో ఒక్కొక్క దానికి ఒక్కొక్క ఫంక్షన్ ఉంటుంది. కానీ when I talk about deep learning, all ANN models will have only one function which is called as sequential. Okay? All ANN models will have only one function which is called as what? Because ANN model okate, our processing is same. So we use this model which is called as what? Sequential. From where am I importing that? From tensorflow.keras.models, I import what? Sequential. Next, I want to add more number of layers. That is, I want to make a dense network. So from tensorflow.keras.layers. From tensorflow.keras.layers, I am importing what? Dense. So what is new here? Importing TensorFlow. TensorFlow.keras.model nunchi I am importing sequential. TensorFlow.keras.layers nunchi I am importing what? Dense. Are you all okay with importing libraries? Machine learning to part of deep learning we require these three libraries. Okay, now you can ask me, madam, deep learning ante TensorFlow annaru kada, malli SQL ani enduku? Okay, for pre-processing, for loading the data set, for doing pre-processing, train test splitting, again we will also use what? SQL. Okay, same. Is there any change in this? Same step. Is there any change in this step? Same again. Creating the data frame is also same. Splitting training data, test data is also the same. Here standardization is being applied. Okay. Now see how standardization is applied. We have a function called standard scalar which we already imported. So we take that standard scalar and we fit to the training data. We fit to the training data and check for the test data. So I write scalar or the variable I'll take and import that module called standard scalar. Now I'll fit that extrain data into that scalar. So I write extrain scaled is equal to that scalar of fit underscore transform with respect to what? Training data. That is extrain. Similarly, I want to transform X test also. Okay. So this is one thing new which is added. Now let's see how do we build ANN model. What was the model that we have imported from TensorFlow? Sequential. Look at this. I write ANN, don't write, you're not developing this model. I write ANN model is equal to sequential of something something something. Now you tell me what is that something something something. Did we import dense? Why do we use that dense? To add layer. So here I have 3 layers, out of which 2 are hidden, the last one is output. Are 2 hidden kabatti I am using which activation function? ReLU. And last the output kabatti I am using which activation function? Sigmoid, because breast cancer is a data set which is a binary classification, andukane I have used sigmoid. So this type of model. But where is forward propagation, where is backward propagation, where is adjusting weights, adanta ledhu ikkada. So itlanti models is covered in your academics, which all other colleges do. But we don't want that to be done. What do we want you to understand? We don't want you to use the libraries which somebody else designed without knowing what is happening inside. We want you to develop the models from scratch. That is understanding forward propagation, loss calculation and backward propagation. మీ academics లో ఇట్లానే చెప్తారు models. Dense, add. Dense, add activation, add hidden layers, output layers, and then finally compile the model using model.compile. Dintlo we give optimizer. Optimizer is equal to gradient descent, or optimizer is equal to Adam. Loss is binary cross entropy, matrix is accuracy. Our formula in the telvadu. What is binary we don't know. How is that happening we don't know. We just know. So this model is like ready-made garments. Okay, we just go buy and wear it. The scratch models is designing your own garments like the way we want. Okay, so more satisfaction with respect to what? Our own designing, because we will design it the way we want, we'll understand what are our requirements and do it. Okay, so this is how. And then training with respect to what? Same, model.fit on what? X-train, Y-train. And then predictions with respect to what? X test scaled. A scaled values e vaadali. Okay. And then finally we will evaluate with respect to accuracy score. Y test is the actual output, Y prediction is the machine predicted output, and then we'll get the accuracy. Okay, this is how we develop the model using what? Libraries. So sequential, dense. Dense is equal to activation function is equal to ReLU, activation function is equal to sigmoid, and then model dot fit low, you give loss, you give optimizer, and then you develop the model. Okay, but we are not doing this. We will go with this. We will go with this model. Okay, that is developing ANN from scratch. థియరీ అంతా తెలుసు, ప్రోగ్రామింగ్ ఆల్సో ఇట్ విల్ బి వెరీ ఈజీ, డోంట్ వరీ. చూడడానికి పెద్ద కోడ్ ఉంటుంది, కాంప్లికేటెడ్గా అనిపిస్తుంది, బట్ యాజ్ యూ హెవ్ రిటర్న్ ఆల్ ద ఫార్ములాస్, జస్ట్ లుక్ ఎట్ ద కోడ్, సీ ద ఫార్ములా, యుల్ అండర్స్టాండ్ ఇట్. దట్ ఈస్ ద రీజన్ ఐ మేడ్ యూ రైట్ ద ఫార్ములాస్. ఓకే, లెట్స్ గో స్టెప్ బై స్టెప్. We have seen all these steps, right? Look at this. What do we do first? Load the data and pre-process. Two pre-processings. What are they? Train, test, splitting, standardization. What are the two pre-processing steps, guys? Train, test, splitting and standardization. After that, activation functions. We are using what? ReLU and sigmoid. See, when we are defining the activation functions, you also have to define derivatives. Endukante backward propagation lo we are calculating what? Derivatives. Andukane when you define the activation functions, you also have to define the derivatives of them. Okay? After that, we calculate what? MSC. So, is MSC correct here? What is the data set? Breast cancer data set kada. Which loss function should be there here? Binary cross entropy. Okay, I have done it wrong wantedly, such that you have to point it out. What is that? Madam, we are working on breast cancer data set where the loss function should be what? Ardhamautunda? I have wantedly chosen it wrong. After that, we do what? Forward. How do we do forward? Z1, A1, Z2, A2 calculations. Next, backward. Look at this now. This is something new that I will teach you. Calculating gradient of dZ2. Z2 is the final output, right? Yes or no? Here I am putting it Z2 because I have taken MSc where I don't have A2. Please understand. Why won't I have A2 for regression? In regression, in the output I don't apply activation. What is A2? Activation of Z2. But in regression, do I apply activation function at the output? No. So directly I go for what? Z2. So if it is regression class, I'll directly go for dZ2. If it is classification, I calculate D8. Don't get confused. Okay. Next, I calculate gradients for what? Z2 is changed with respect to what? W2 and B2. So I calculate gradients for W2. I calculate the gradients for B2. After that, W2, B2. Before that, what do we have? A1. So I calculate gradients for A1. A1 I am computing with respect to Z1 and dW1, dB1. So I will calculate it for Z1, I will calculate it for dB1 and dW1 and D1. Is it clear, everybody? First, gradient derivatives for what? Z2. Second, derivatives for W2, B2. Next, derivatives for A1. Next, derivatives for Z1. After that, for W1 and D1. Adi raskon. Calculate derivatives for dZ2. 1. Calculate derivatives for dZ2. After that, dW2, dB2. First one is dZ2. Second one, dW2, dB2. Third one, dA1. Fourth one, dZ1. Finally, fifth one is dW1, These were the 5 weights that I was talking about. Okay. What are these 5 calculations, guys? dZ2, dB2 and dB2 and dW2. After that, dA1, dZ1, dB1 and dW1. Okay. Now look at this. Look at this diagram. All of you please look at this. First I'll come from back. Look at the arrow marks. First I calculate A2 or Z2. After that W2 and B2. After that A1. Look at this in between circles. Okay. If it is classification, I have A2. If it is regression, I have only Z2. So first I start with that. Update the weights W2, B2 and calculate the gradients again. Gradients for A1, gradients for Z1, gradients for W1 and B1. Input name Jaya Malli. Input is as it is. Okay. So this is how step by step we calculate the gradients. Okay. These are the formulae for gradients. You please write it down. dz2 is equal to, what is the final output? Actual minus predicted. Okay. What is y cap and what is y? Predicted and actual. Okay, y minus y cap or y cap minus y. Okay, dz2 is equal to y cap minus y. If suppose I have a2, what do we write? a2 minus y. That's all. Next, dw2 is equal to, stop here. Look at dw2 and dw1. I have 1 by m. Means what? For all the samples I have to update the weights, right? Not only w1. Weights of what? All the x weights that are generated. And can I write 1 by n. 1 by n of dou2 that was calculated earlier. Into A1 dot transpose. Why am I taking A1 dot transpose? Because I want to calculate all the row values. Okay. So usually it is 2 by 2 matrix, but I want to take it in one matrix. So I take A1 transpose. And then DB2, do1, DW1, DB1. The reason why I made you write the formulas is tomorrow it will help you in writing the code. You can refer this book, sit and write the code, not a problem. So how are we updating the parameters? W is equal to W minus alpha, the learning rate. Okay, write this formula. W is equal to W minus alpha into DW. Okay. Loss calculation you know. Let's get back to the exercise. Please understand this exercise very carefully. I'll try to explain this as much as clearly and easily understandable as possible. Okay. So what is our exercise all about? Now close your books. We don't need the books now. So what are we trying to develop here? I didn't take any data set. I don't want to make the task complicated. I want you to create your own data set. The data set is all about what? Developing which gate? XOR gate. So what is the problem statement? Implement a 2-layer ANN to classify the XOR problem using NumPy. No TensorFlow, no sklearn, nothing. I want you to use only NumPy and develop a ANN model for which problem? XOR problem. Is it clear? How many input layers? How many input layers? 1. With how many neurons? 2. Why? XOR gate has only 2 inputs. 0, 0, 0, 1, 1, 0, 1, 1 combination. The inputs are only 2. X and Y. X and Y. So this X and Y can be either 0, 0, 0, 1, 1, 0, 1, 1. Combinations. Can inputs and 2. And the correct 2. How many hidden layers here? 2. And which activation function do you have to use in hidden layers? 3. How many output layers? 1. How many outputs do you have for XOR gate? 1. So that should be 1. Which activation function in the output layer? Sigma. Are you all clear with this? Are you all clear with the problem statement? This is the XOR gate. What is the functionality of XOR gate? 0, 0, 1, 1, the output should be 0. 0, 1, 1, 0, the output should be 1. That is, if both the inputs are same, the output should be 0. If the inputs are different, the output should be 1. Let's see how do we do that. What is step 1? Import libraries. How many libraries did I import? How many libraries? Only 1. Second step? Read the data set. Here I don't have any data set. We have to create the data set. So I am creating X and Y. What is X? np.array of all the 4 combinations of XOR gate. That is 0, 0, 0, 1, 1, 0, 1, 1. What is Y? Output possibilities. What are the output possibilities I have? For 0, 0, it should be 0. For 0, 1, it should be 1. For 1, 0, it should be 1. For 1, 1, it should be 0. Did I finish defining the data set? Yes or no? Okay. So do I have to do data pre-processing for this? Do I have to do standardization, normalization for this? Do I have to do train test split for this? Simple data set. But tomorrow when we give you a data set, you should do all that. I am just trying to explain the model. Are you getting my point? ఇదే steps. కానీ అక్కడ ఆ స్టాండర్డైజేషన్ నార్మలైజేషన్ చేసుకోవాలి. విల్ గివ్ యూ ఆ డిస్క్రిప్షన్ పైన తాంత్రిక్లో అది ఎట్లా చేయాలి అని ఇస్తాం మేము. డోంట్ వరీ అబౌట్ ఇట్. ఓకే. నెక్స్ట్ స్టెప్ ఈజ్ వాట్? Initializing weights and biases. That is defining the parameters. Initializing the network parameters ఉన్నాయి కదా. So what are they? W1, B1, W2, B2. Random seed. Yesterday I told you about random. Once random is used, first cycle ki weights అన్ని random గా generate అవుతాయి, which will not be changed. Change అయిందనుకో, the model will find difficult. Change should be done when? While backpropagation, not in between. సో అందుకనే వీ హ్యావ్ టు యూజ్ ర్యాండమ్ సీడ్. ర్యాండమ్ సీడ్ పెట్టకపోతే ఇష్టం వచ్చినట్టు వెయిట్స్ చేంజ్ అయిపోతూనే ఉంటాయి ఇన్ బిట్వీన్. ఓకే. సో డోంట్ ఫర్గెట్ టు యూజ్ వాట్? ర్యాండమ్ సీడ్. ఓకే. సో ఐఎమ్ ఇనిషియలైజింగ్ వాట్? W1, B1, W2, B2. How are we generating weights? Randomly. So which function in NumPy am I using? Random.randn. So np dot random.randn 2, 2. 2, 2 అంటే input to hidden layer. How many neurons do I have in input layer? 2 neurons. How many neurons I'm having in hidden layer? 2. అందుకని 2, 2. Is it clear everybody? Next, how am I generating bias? Bias is a very small term. So I'm using zeros function of NumPy. So I say np dot zeros in brackets 1, 2. ఎందుకంటే first hidden layer, that is, I am taking the first hidden layer in which it has 2 neurons. Because bias is only added once for all the neurons. So how many neurons are there in the hidden layer? 2. So first hidden layer, 2 neurons. That is the reason I am adding that bias term. Is that clear everybody? Why bias is 1, 2? Only one hidden layer which has what? 2 neurons. Okay. Next, look at W2. np dot random.randn. Why did I write 2, 1? W2 is connection between what? Hidden to output. How many neurons are there in hidden? 2. How many neurons are there in output? 1. Hence I write 2, 1. Are you getting my point? Our diagram gurtu techukondi. W1 is connection between input to hidden. Input lo I have 2 neurons, hidden lo I have 2 neurons. Hence 2, 2. Whereas W2 is connection between what? Hidden to output, where I have 2 neurons in hidden, 1 neuron in output. Hence I write 2, 1. Coming for bias 1, hidden layer bias with 2 neurons. What is bias 2? Output layer bias which has only 1 neuron. Only one bias term for the output layer which has 1 neuron. Hence I write 1, 1. Ikkada confuse avutaru andaru. Okay, this is how clearly you have to write what? W1, B1, W2, B2. This is initializing parameters. Are you all clear with this? Yes or no? How do we initialize weights? Random.randn. How do we initialize bias? np dot zeros. Is it clear everybody? Look at that. 2, 2 because 2 inputs and 2 neurons in the hidden layer. Bias 1, 2 is why? 2 biases for the, I have 2 neurons. Andukane one bias term for 2 neurons. 1, 1 ante one bias term for 1 neuron. Is it clear everybody? Okay. Now define activation functions. What are the activation functions I need for XOR gate? XOR is a binary classification. So ReLU for hidden, sigmoid for output. What is the formula for ReLU? Please look at your notebooks now. What did you write the formula for ReLU? Max of 0, x. Now see, what did I write? Define ReLU of x, return what? np dot maximum of 0, x. np dot maximum of 0, x. Next, ReLU derivative, we know how to calculate derivatives of that. Okay. After that, sigmoid. What is the formula for sigmoid? 1 by 1 plus e power minus x. So return 1 by 1 plus np dot exponential of minus x. అర్థమైందా ఇప్పుడు? Did you all understand how did we define functions? What are the functions that I have defined, guys? ReLU and its derivative, sigmoid and its derivative. Okay. Now defining the hyperparameters. What are the hyperparameters? Learning rate, because for updating I require learning rate. For training I require number of epochs. How many times I want to run this? So what are the update parameters? One is learning rate, one is number of epochs. Okay. Now look at this. ఇది పెద్దగా అట్లా కనిపిస్తుంది. It is very simple. Okay. Don't worry. ఇదంతా మీకు లైన్ బై లైన్ వచ్చు. I'll explain you line by one. Okay. First I write for, yeah. Okay. I've split that. Okay. First I'll write for I in range of epochs. What do you mean by that? I want the entire model to be trained for this many number of epochs. First I write forward propagation. What are we doing in forward propagation? Code udakandi. What are we doing in forward propagation? Z1, A1, Z2, A2. What is Z1 written as? Summation of Wx plus B kada. A summation etla chestamu using dot product. So np dot of what? X W1 plus B1. What is A1? ReLU of Z1. What is Z2? np dot of what? A1 comma W2 plus B2. What is A2? ఈ పెద్ద కోడ్లో ఫస్ట్ పార్ట్ అయిపోయింది. అది చూడగానే అమ్మో అనుకున్నాం కానీ వాట్ ఈస్ దాట్? ఓన్లీ ద ఫార్వర్డ్ ప్రాపగేషన్ విచ్ యూ క్లియర్లీ నో అబౌట్. Did you all understand how forward propagation is done? Yes or no? Any doubts in this? Next is loss calculation. What is the binary cross entropy loss formula?
Y into minus log of y into minus
1 by m, mean product of what? Minus y log of
y prediction
y prediction plus 1 minus y log of minus log of 1 minus y prediction. The same thing I have written as a formula. Y prediction is A2. Yes or no? Y prediction is what? A2. So np dot minus of n minus np dot mean y into np dot log of A2 plus 1 minus y into np dot log of 1 minus A2. Is this matching with the formula? Yes or no? So in this big code that you said, two parts are done. What are those two parts? Forward and backward. Sorry, forward and loss. Backward. What is backward? Calculating what? dz2, dw2, db2, da1, dz1, dw1. అక్కడ అదే ఉంది. Is there anything new? What is dz2 here? A2 minus y. Prediction minus original. Prediction is what here? A2. What is dz2? dw2 formula చూడండి. What is dw2? 1 by m. That derivative into what? A1 transpose. Look at that formula. np dot product of what? A1 transpose into dz2 by what? By length of y. And how many samples you have in y? Is that clear, everybody? Similarly, I have written it for what? db2, db1, dz1, d1, dw1, db1 as per the formulas. Is that clear, everybody? ఇప్పుడు చూడండి. For I in range of epochs, what did I do first? Forward. After that, loss. After that, backward. After that, updating the weights. How are we updating the weights? How are we updating the weights? The new W2 is equal to the old W2 into the learning rate. Okay, the same formula. Okay, I update the weight, and for I have taken 5000 epochs. No, 5000 1, 2, 3, 4. I don't want to print it like that. After every 1000 epochs, I want to print the loss. So I say if epoch percentage is 1000 is equal to 0, print the loss for 1000. Is it clear? After that, I'll test the model. What do you mean by testing? Applying that 0, 0, 0, 1, 1, 0, 1, 1 for all that and generate the outputs. Now results చూడండి. How many epochs did I take? 5000. For every 500 epochs or 1000 epochs, I want to run the code. అక్కడ చూడండి. First, what was the loss? 0.69 అంటే 70% loss, which means accuracy is only 30. After running for 500 epochs, the loss is reduced or increased? Reduced to what? 62, which means accuracy is how much? 38. After that, for 1000 epochs, the loss is reduced to 48, and the accuracy is around 52. After 5000 epochs, the accuracy is how much? So the loss is how much? 47. So the accuracy is around what? 53. So when you observe this, 1000 నుంచి 5000 కి లాస్ ఏమైనా పెద్దగా చేంజ్ అయిందా? So which means that no matter how much you do, we're not having change. అందుకనే I stopped it till 5000. నువ్వు 20,000 పెట్టినా 30,000 పెట్టినా it is around 47, 43 only, which means that the loss is not decreasing. అంటే accuracy is how much? Around 50. Okay, now look at the predictions. 0 0 input ఇచ్చినప్పుడు, okay, what should be the output for 0 0? 0. కానీ ఏమొస్తుంది మనకు అవుట్పుట్? 0.662 అంటే 1 వస్తుంది. The actual output is 0, but the predicted output is what? 0.662 అంటే it is 1. Okay, for 0 1 combination, what is the prediction? 0.662 అని వస్తుంది. The actual is 1. So ఇది మ్యాచ్. Okay. Third case, 1 0 ki the output should be 1, it is 0.662. Okay. Last case, 1 1 ki the output is 0. Where is the output going wrong here? First case. అందుకే accuracy is how much? 53, 54 only. Madam, inni epochs చేసినాము, ఇన్ని చేసినాం కదా, why the error is less? Two reasons. We have taken only one hidden layer. If you add more hidden layers, maybe you may increase the accuracy. కానీ ఎన్ని 100 hidden layers చేసినా కానీ రాదు. ఎందుకు అంటే the data is very small. I told you that clause, right? Changing number of epochs may increase the accuracy, like what you can observe here. Changing the number of layers may or may not improve the accuracy. That again depends on what? The data set. ఇక్కడ 4 samples ఉన్నాయి data set లో, 0 0, 0 1, 1 0, 1 1. So no matter what you do to the basic RNN, you will not get the good results. Is that clear, everybody? Some more things that can be done. ఆ సమ్ మోర్ థింగ్స్ ఏంటి అంటే చేంజింగ్ యాక్టివేషన్ ఫంక్షన్స్. చేంజింగ్ వాట్? యాక్టివేషన్. ఆ రేలు బదులు టాన్-H పెట్టండి, అయితే సిగ్మాయిడ్ పెట్టండి. ఓకే, ఎట్లన్నా పెట్టి యూ చెక్ ద అవుట్పుట్. దట్ ఈస్ వన్ థింగ్. రేలులో డిఫరెంట్ వర్జన్స్ ఉన్నాయి మళ్ళీ. ఏంటది? లీకీ రేలు, అవి పెట్టి చెక్ చేయాలి. సో ఆల్ దీస్ ఆర్ కాల్డ్ యాజ్ పారామీటర్ ట్యూనింగ్స్, హైపర్ పారామీటర్ ట్యూనింగ్స్. ఓకే, చేంజింగ్ ఆప్టిమైజర్స్ మే ఆల్సో హెల్ప్. Changing optimizers may help, adding more number of layers may help, adding more number of epochs, that is training the model n number of times may help. Okay, is it clear? Optimizers, changing the layers, taking the number of epochs, changing the activation functions. In all possibilities anni models lo try cheste we will get the desired accuracy. Is that clear, everybody? So did you all understand how do we develop ANN model from scratch? How do we develop ANN model using libraries? How do we develop it using libraries? Sequential function. Importing sequential function from where? From TensorFlow.Keras.models. Adding dens to it. Is that clear? If you want to develop it from scratch, what do we do? Activation. Initialize the parameters W1, B1, W2, B2. Define the activation functions. Train the model, in which we first do what? Forward, loss, backward, iterate the process by updating the parameters and then testing the model. Is that clear, everybody? So this is all about how do we develop ANN from scratch. Is that clear, everybody? Yes or no? So tomorrow you will be given one exercise where you have to develop ANN from scratch. We'll give you a data set. You have to read the data set, perform standardization, perform train test splitting, and the rest of them would be C. Is it clear, everybody? So all the best for tomorrow's session.